Uh, Today we are going to discuss corrosion inhibition. Here this thing can be done by using some inhibitors. Try to understand that. If anybody asks what is corrosion inhibition, then you have to tell it is a process in which certain kind of chemicals can be used to reduce the rate of corrosion. This is a process. But if anybody asks what do you mean by inhibitors, they are the substance being used to reduce the rate of corrosion. And therefore, in the examination, wherever any question comes, if it comes in the form of inhibition, then you have to explain that it is a process. And if it comes in the form of inhibitors, then you have to tell it is a substance being used in a corrosive environment in order to reduce the rate of corrosion. And therefore, corrosion inhibitors are the substance which are being used in a calculated amount in a corrosive environment in order to reduce the rate of corrosion significantly. And similarly, if anybody asks what do you mean by corrosion inhibition, then you have to tell it is a process in which certain suitable chemicals are being used in calculated amount in order to reduce the rate of corrosion significantly. This is the difference. Okay? Now, actually, whether it is corrosion inhibitors or inhibition, it may be of two types. Let us start with anodic inhibition. And number two is cathodic inhibitors. And if we start with anodic inhibitors, these are actually high oxygen containing molecules like phosphate, chromate, and other ions of transition element. And this compound actually form insoluble or some kind of compound with newly produced metal ion at anode, which are being deposited on the anodic surface in the form of a barrier, as a result of which your anode will become protected. So once the anode becomes protected, the rate of anodic reaction will be reduced. As we know that at anode oxidation takes place, and therefore as oxidation takes rate of oxidation gets down, automatically rate of reduction will be go down. This technique is very much effective, but unfortunately may be very, very dangerous also. Actually, if any part of anode actually remain unprotected due to the depletion of that is inhibition anodic inhibitors, then there is every possibility that local type of corrosion, that is you know that localized type of corrosion, but local attack will initiate, where your anodic area will be very, very small and cathodic area will be very, very large, and rate of corrosion will be very, very high. So this is all about your anodic inhibition. Now let us see cathodic inhibition. As we have seen earlier, in electrochemical type of corrosion, there are two types of mechanism, either in case of acidic environment or in neutral environment. So in acidic environment, what is the corrosion reaction? You might have seen earlier, H plus will gain one electron producing H, then H plus H will be produced, and therefore hydrogen will be released. This is the cathodic reaction. This is your cathodic reaction. And therefore, if you analyze the reaction very, very carefully, the rate of corrosion can be controlled by reducing the diffusion of H plus at the cathode. This is one way. Or oblique and by increasing the over voltage of hydrogen evolution. Try to understand that. If we analyze this reaction, so then corrosion, how we can control corrosion? It can be controlled either by reducing the diffusion of H plus ion at cathode or by increasing the over voltage for hydrogen evolution. This is how we can actually control corrosion. Here, diffusion H plus ion can be reduced by using organic inhibitors like amines, heterocyclic nitrogen compounds, and this very compound has a tendency to get deposited on the metal surface, and thus metal surface become protected. Arsenic and antimony oxide can also be used as inhibitors for the second situation, as they can form adherent layer of antimony and arsenic at the cathodic area, as a result of which our voltage get increased. And this is two different ways how we can actually control corrosion. Now, in case of acidic environment we have seen, now let us see what happens during neutral situation. In neutral situation, what is the cathodic reaction? Do remember, that is your water, liquid, plus 2E, plus half of oxygen. It will give you 2H aqueous. This is what happens in neutral situation. And therefore, you can easily conclude that if we want to control corrosion, then what is the best option? If we can actually eliminate oxygen from the corrosive environment, automatically rate of corrosion can be controlled. Or another option is there, if we can reduce the diffusion of oxygen at the cathodic area. These two options we can go for protection of corrosion. The first one, how it can be eliminated, it has already, we have discussed earlier, by reducing certain suitable reducing agent like sodium sulfide or hydrogen. We can actually do that. And second one, to do actually the second option, what we have to do, we have to use certain inhibitors like zinc, magnesium, nickel compound. And this compound will react with hydroxyl OH ion, and they will make insoluble hydroxide, zinc hydroxide, magnesium hydroxide. The being insoluble, they will be deposited on the cathodic surface. So once cathodic surface gets protected, reduction reaction will be stopped. Once reduction reaction will be stopped, automatically rate of oxidation will be reduced, and thereby rate of corrosion will go down. This is how we can actually go for protection against corrosion by using certain inhibitors. To summarize, we can tell that inhibition is a process where some suitable chemicals are being used in calculated amount in order to reduce the rate of corrosion, and corrosion inhibitors are the substance which are being used to reduce the rate of corrosion. It is basically two types, anodic and cathodic. And again about anodic and cathodic protection, what we do, I have explained in detail. Please go through the video carefully. If there is any doubt or any confusion, it will be cleared in our next lecture.